Hi everyone, this is Peter Online Computer Network Engineering Tutorial. I am here to, talk about Ethernet cabling. Okay, Ethernet cable, Ethernet cable is the, cable used, you know, to interconnect nodes like, you know, computers, printers, okay, access point, voice over IP phones, and other devices to the switch to form a local area network. Okay, Ethernet cables can also be used to interconnect, switch and router to router. Okay, and router to router. Okay, and these Ethernet cables ranges from, categories. There are so many categories of, these Ethernet cables, which, start from Cat3. Okay, this is Cat3 cable. Cat3 cable has the speed, you know, Cat3, has speed, can transmit data at a speed of, 10 megabits, 10 m, 10 megabits, okay, per seconds. Okay, another one is category 5, that's Cat 5. Cat 5, which has, you know, has a speed of, okay, 100 megabits per seconds. Okay, and has a, Cat 3 and category 5 also can transmit data at the range of, 100 meters. Okay, 100 meters, 100 meters. Okay, 100 meters. Yes, they have a, okay, range of 100 meters from, computer to switch. Okay, now another one is Cat 5e. Cat 5e. This E means enhanced. Okay, Cat 5 enhanced. Enhanced. Okay, which has a speed is 1 gigabit. That is 1000, okay, megabit per second. Okay, 1000 slash 1 gigabit per second. Okay, and the range of 100 meters. Okay, from switch to, computer. Okay, so this range is signal range that can transmit data, at a range of 100 meters, you know, 100 meters. So another one is Cat 6. Cat 6 cable. This Cat means category 6. Category, okay? This Cat 6 is also, speed of, okay, speed of 10 gigabit per second. 10 gigabit. But at the range of 55 meters. 55 meters. Okay? Cat 6, Cat 6A. Cat 6A means, this A means augmented. Augmented. Okay? Augmented. This augmented is a kind of, the copper wires inside, okay, are foiled, in order to protect it from electromagnetic interference, okay? You know, foiled. The copper wire is foiled, okay? to protect from electromagnetic interference. It can transfer, data and also the, 10 gigabit per second. Okay, and also at the rate of, at the range of 55 meters. Okay, Cat 7. Cat 7 can, transmit that at the speed of 100 gigabits per second, but at the range of 15 meters. 15 meters. Okay? So these categories from this Cat 5, from Cat 6 to Cat 6A and to Cat 7 are STP cables. They are called shielded twisted pair cables. While from here, Cat 5E, okay, to Cat 3 are UTP, unshielded twisted pair, cables. Okay, from Cat 6 to Cat 7, that's Cat 6, Cat 6A, Cat 7, okay, can protect signal from crosstalk. These cables are shielded twisted pair. They can be used in a factory where heavy equipment are used and without any problem. Okay, but unshielded twisted pair cannot be used in a noisy, environment where, heavy equipment, you know, are used, okay, because they will be interfered, signal will be interfered, okay. So, and there's something called crosstalk, okay, because category 5, Cat 3, Cat 5, Cat 5E are prone to electromagnetic interference, okay, which is crosstalk, noise, okay. So there's something called signal degradation. They can be affected, by noise, electromagnetic interference. Why Cat 6, Cat 6A, and Cat 7 are shielded twisted pair cable. Okay, so they are not prone to electromagnetic interference. So this is the difference, these are the difference between these, cables. Okay, because they are, twisted shielded, and each of these cables has 4 pairs of copper wires inside the cable. Okay, they have 4 pairs. Okay, like in Cat 5, Cat 5E, can transmit at the rate of, 100 megabit per second using 2 pairs of wire. One pair is transmit and one pair, is receive. But in a situation, even Cat 5E can transmit, 1 gigabit per second. So in where you can, in a situation where you want to transmit a gigabit, like 5E, 6, and 6A and 7, has the capacity to transfer gigabits, from 1 gigabit to 100 gigabits of data. But in this case, 8 wires are used. That is 2 pair for transmit and 2 pairs for receive. Okay, so there is also types of cables, types of these cables, which is straight through cable. Straight through. Okay, straight through. Straight through cable. Straight through cable is like this. Let's say this is the connector. At both ends of these cables are, connectors called RJ45 connector. Okay, RJ45 connectors at both ends. These are the connectors here for straight through cable. 1, 2, 3, 4, 5, 6, 7, and 8. That is 1, 2, 3, 4, 5, 6, 7, 8. Okay, don't mind my drawing. In straight through cable, one copper wire run from the other, end to the other end. Okay, okay, because at both ends, RJ45 connector are terminated. This is RJ45 connector, RJ45, RJ45. And from pin 1, this RJ45 also has, 8 pins, just like the wire has 8 copper wires. So now from 1 to 1, from 2 to 2, from 3 to 3, and from 6 to 6. Okay, this is how straight through cables are made. Okay, that can transmit at 100 megabit per second. Now, which means two and sorry, 1 and 2 are for transmit here, transmit, while 1, 2 here, for receive. Okay, now 3, 6 for transmit, and 3, 6 here for receive. Okay, this is 3, 6. 3 and 6 here is for receive, while here is for transmit. Okay, look at 1 and 2. 1 and 2 here. 1, 2 for transmit and for receive. Okay, so, but in a situation where, let's say this cable is category 5E, category 6, and cat 7, and they want to, because they have the capacity to transmit gigabit, of speed. So now, which means all the cables will be used. But let's say this is for 100 megabit, data transfer. So even though it's 100 megabit data transfer, but these cables are made like this, which means this is unused from 8 to 8, 7 to 7, unused. Okay, unused. Okay, 5 to 4 to 4, unused, unused. Okay, and 5 to 5. 5 to 5 is unused. The cable used here is 1 and 2, and 3 and 6. Okay, but in a gigabit situation, the 8 pins are used, which means, four, cables are used here for transmit. 4 copper wires are used for transmit. That is 2 pairs are used for transmit, and 2 pairs are used for receive. So another cable is, and straight through cable. Straight through cable is for thread through. Is for, okay, connection of, router, router to router. Router to switch. Okay, straight through cable, router to switch. This is switch, router to switch, and switch to computer. This is a computer system to switch. Okay, and that is it. And hub, computer to hub. Okay, computer to hub, computer to hub. Okay, switch. Okay, is router. Any, device that operates in different layers of OSI reference software, because this router and computer operate, in layer 3 of OSI reference model. Why, switches operate, in layer 2, which is data link layer, and the hub operates at, in, thread through cable. Okay, hubs operates in layer 1, physical layer. So that is it. So let's go to crossover. Let's go to crossover cable. Okay, crossover cable, sorry. Crossover cable. This cannot write. In crossover cable, this is the RJ45 connector. Okay, let's say this is RJ45 connector. Okay, this is 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, and 8. This is 1, 2, 3, 4, 5, 6, 7, and 8. So in crossover cable, one pin comes to 3, and one this side comes to 3. 2 here comes to 6, and 2 here come to 6. Sorry, 6. Come to 6. Okay, which means 1 and 3. 1 and 3. Oh, sorry. 1 and 3 for transmit. Why 2, 6 receive. Okay, and 2, 6 here for transmit, and 2, 6 here is for receive. Okay, so in gigabit Ethernet, so it's like this: 4 to 7, 4 to 7 here. Okay, 5 to 8, and 5 to 8 here. Okay, in gigabit, 2 pairs of wires are used. Okay, that is 8 wires. The 8 copper wires are used in gigabit. Okay, so that is how it is. And in these 2 pairs, which means 4 to 7 here, 4 to 7, 5, 8, 4, 7, 5, 8, can also be for, transmit, and, just like that here, for receive. Okay, so another one is, okay, sorry, and crossover cable is for router to router connection, router to router. Okay, router to router, switch to switch, devices of similar, layers. Okay, this is switch, this is switch, switch to switch. Okay, crossover cable. We connect computer to computer, which is peer to peer. Computer to computer. Okay, crossover cable. Computer to computer to router. Remember that computer operates in layer 3 of OSI reference model, just like router. Okay, computer to router with crossover cable. Crossover. Use crossover cable to connect these devices. Okay, crossover. Okay, So there is another, cable also called rollover cable. Rollover cable it's not used for data transmission, just like others. Rollover cables are used for, from computer, ROS 232 to router console port for configuration. Okay, at the back of computer is, T Telecommunication Industry Alliance stroke Electrical Industry Association, ROS 232 at the back of computer, to console port, to router or switch, console port for configuration. Okay, so and this is how these rollover cables are. This is also connectors. Okay, this is also connectors at both ends. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. So pin 1 comes to pin 8. Pin 1 here comes to pin 8. Okay. Pin 2 comes to pin 7. While pin 2 here comes to pin 7 here. Pin 3 comes to pin 6. And pin 3 here comes to pin 6 here. Pin 4 comes to pin 5. While pin 4 here comes to pin, 5, for router, for, configuration, for configuration. You don't connect this to computer's RJ45 connector. You connect it to this at the back of computer system to router's console port or switch console port, okay, for configurations. And when you use this cable, after the connection, you go to computer and launch what is called hyperterminal software or PuTTY. Okay, most people use PuTTY, some use hyperterminal. You launch it and you select some kind of, so you hit your OK and you are into, routers or switch command line interface where you can apply some commands in order to configure a router or switch. So this is, what cable, is all about. If you like this video, don't hesitate to share it. And I'll see you in the next tutorial. Thank you.